Okay, so this section right here with molar mass, go ahead and quiet up, guys. It's actually very, very easy. Up until now, all we've been working with are elements, correct? All we've been doing is elements. And so where do we find the mass for any element that we need to use in dimensional analysis?
On the periodic
table. Okay, we're not always going to be dealing with elements. Sometimes we're going to be dealing with compounds. So in order to know the mass of your compound, you have to be able to add up those masses. So this is called molar mass. And it's literally as simple as that. You're just adding up all of the masses of each individual element. So we have 4 examples we're going to look at. The units for molar mass are going to be gram per mole. This is also a conversion factor because 1 mole of anything is equal to the mass of that compound or element from the periodic table. Okay, so the first one, we're going to calculate the molar mass of H2O. And so what you're going to do is you're going to list, and this is the minimum work that's required. You're going to list the number of atoms. Okay, so 2 H's, 1 O. All I did was look at the formula. Over here you're going to say, okay, 2 times whatever the mass of hydrogen is. So 1.01. I get that from the periodic table. I keep 2 decimal places. Okay, and then 1 times 16, that's the mass of oxygen. Okay, now this right here is the minimum amount of work that's required. I am going to recommend that out to the side, you go ahead and work those individually. So 2 times 1.01 is 2.02. Because the next section with percent composition, you'll need to use that step.
And we're doing percent composition after this.
Right after this. So this is just molar mass. It's just adding up the masses. And then this is obviously 16. So what is 2.02 plus 16?
18.02.
18.02. And then the unit is grams per mole. We're done with that problem. That's it. All you're doing is adding up the masses. It's that easy.
I like those.
Okay?
That's easy.
Yeah, it's very, very easy. Now, like I said, the minimum amount of work is showing this right here. Well, obviously listing this. So if you didn't do this last step over here, you could type all of this into the calculator. Just remind yourself that you are adding the 2 of these. Okay, you're multiplying 2 times 1.01, and then you're adding that to 16. So once you get into the flow of things, you at least need to write it down on the paper, and then you can just type that all into the calculator at once.
Okay, so 2H, what's below 2H?
1 oxygen, so you're counting up the number of atoms in the compound. Okay, so B. B is ammonia. This was one of the compounds from last chapter that you need to have memorized. What is ammonia? Now that's ammonium. Ammonia is a compound, NH3. Very good. Okay, so if this is my compound, I'm going to list my elements. 1 N, 3 H's. I'm going to multiply each of the elements by their mass. So 1 times 1401, 3 times 1.01. This is 3.03. This is 1401. And then I'm just going to add those up. 1401 plus 3.03 is
17.04.
04, and that's it. Grams per mole.
Is it going to always be grams?
When you're calculating molar mass, so like if the problem said what is the molar mass of this compound, the unit's gram per mole. Now, the other step that you're going to see this is you're going to use this in dimensional analysis. This right here turns into 1802 grams over 1 mole. It's your conversion factor. Okay, so that's when you're going to use it in on the next page. Okay, next one. C is C3H8. So we're going to list our elements. Okay, we're going to find the mass of each carbon and hydrogen. So 3 times 12.01, 8 times 1.01. Off the side, I always work them out just because that's what I do for percent composition. But 3 times 12.01 is what?
36.3. I mean,
3.
0.3.
And then 8 times 1.01.
8.0.
So when you add those together, what's the total molar mass?
44.11.
44 point, you said 11?
I think so.
Okay. And then unit is grams per mole. Very good. Those seem pretty easy, correct?
Yes.
Okay, the hardest thing that you're probably going to have to deal with molar mass is when I don't give you the formula and you have to write the correct formula from the name. This is, like I said, from last unit. You're going to have to know this throughout the entire rest of the year. So on D, molar mass of barium phosphate, you have to write a proper formula before you can count up the masses. So think back at last unit, barium phosphate. What is barium?
BA.
Ba, and what charge does barium usually have?
Minus.
2 plus.
That's what I meant. And
Okay,
phosphate has a 3.
It's PO
4.
4 3 minus. So when I crisscross these, write a correct formula first. What is that?
BA 3 and then in parentheses PO 4 and then 2.
PO 4 2. So if you don't get this step right, you miss the rest. Okay. Now, let's count these up. So I've got 3 BAs. Remember, when you're dealing with parentheses and polyatomic ions, the 2 outside multiplies to every element inside. So we have 2 phosphoruses and 8 oxygens. Okay. Now, what is the mass of barium? And on your homework, make sure you use the orange periodic table because that's what the key that I have uses. So find barium. What's its mass?
137.3.
Okay. What is phosphorus?
Phosphorus is 30.97.
Okay. And then oxygen is?
Oxygen is 16.
And you're going to end up memorizing oxygens and hydrogens and probably sulfurs without even knowing it. Okay, now you can do the individual masses here and then add them up, or you can type this entire thing. I don't care which one you do, but when somebody gets an answer, if you will let me know. What?
600.
How you get so fast?
601.993.
9-3? Go ahead and practice it, type it in, see if anybody gets anything different, but I think that is what it is. Okay? And go ahead and do that. You done this page? You can print it on. What is it?
Gee, how do you get, oh, it's changed. What's the one challenge?
Now, on molar mass calculations, you can make a note to yourself. You need to keep two decimal places on all of your answers. So don't worry about significant figures right here. You're keeping 2 decimal places on all of your answers. Any questions on that? What do you need, Ben?
Is that just, is D, like, what's the answer? Is that just?
This is the final answer when this is multiplied, this is multiplied, that's multiplied, and then you add all those up. So this right here would be the minimum amount of work. Sometimes people like to just take it that step further and do those individually and then add those up, and that's fine. Either way. Any questions on that? Okay, so just like your homework that we just got done doing, okay, you're going to use molar mass in dimensional analysis. Now we're going to be working with dimensional analysis of compounds. So first example, calculate the mass of 1.48 moles of potassium oxide. So a couple things are going on here. I'm going to write what's given over 1. However, what is the formula for potassium oxide? Okay, go back to your last unit, unit 3. What is potassium?
K.
And what ions does it form? Okay.
1.
Plus oxide,
O minus.
O2 minus. So when we crisscross those,
You get K2O.
okay, so this is 1.48 moles of K2O over 1. This is very similar to a lot of the stuff you're going to see on the test and quiz coming up. Now, how do I go from moles to gram? If moles is on top here, what unit do I put on bottom? Moles. Remember, you always have to follow your unit. It's going to cancel out. And then moles goes to gram. We always put a 1 with our mole. And then how do we find the mass of K2O? We add up the masses, so molar mass. So you do need to show work. So 2 Ks, 1 oxygen, 2 times, what is potassium?
39.098.
So 1 0. You're keeping 2 decimal places. Oxygen is 16. So somebody add that up for me. And I'm just gonna 2 times 39.10, and then add 16 to that.
94.2.
94.2. Okay. And so this is the mass of potassium oxide. We're going to insert that mass over here. 94.20. My moles cancel. Okay, now all I have to do is multiply across. So 1.48 times 94.20. And think sig figs. How many sig figs should my answer have?
2.
3.
3.
1.48 is
It would
3.
be 139.
So 139 grams of K2. Oh, that would be my final answer. So this is the minimum amount of work that needs to be shown on all of these problems. So make sure on your homework, when you have a problem like this and you have to calculate molar mass, make sure you show that as a part of your steps. Okay, you can go ahead and do the next one by yourself. What is acetic acid? That's part of the problem, is you have to find out what the formula of acetic acid is before you can solve this. Think back at acid nomenclature. Acetic acid comes from which polyatomic ion? Acetate. So what is acetate? And then what's the charge on that?
Negative.
Negative. So when I add an H plus to it, what's my acetic acid formula? You just add it together. So that's acetic acid. So when you're calculating the mass, make sure you factor that in to your answer. So 4.85 moles of acetic acid, convert that to grams real quick. Not a way to put that on pause.
Wait, do we have to do that second? The thing that boxed, the second thing that's boxed?
This thing right here?
Yes.
Well, that's the formula for this. You have to know the formula before you can calculate the correct molar mass.
What if you know it? Then do you have to write out the
Oh, if you know what that is, that's fine. You didn't have to do that step right there. But, and then while you're working on that, I'm going to show the work, and then you can double check your answers with mine. So don't look up here until you get done. When you get done, check your answer up at the board, and then check if you get a different answer where yours changes from mine. And the part that most students will miss on their homework is they'll forget to show the work for this right here. You have to show me how you calculated molar mass. Okay, this would be like, I think this would be like an 8 to 10 point problem. I was over here when I was thinking. And now the dimensional analysis should be very similar to what you just got done learning last section, except we're no longer dealing with just elements, we're dealing with compounds. So if we just had a single element, this part right here would be simple because we could just look at the periodic table. But since we're dealing with compound, we do have to add them up. Okay, everybody get it? Calvin, your question? Very good. Okay. I think most of you look like you understand that. Now, the next two problems, we're no longer going from moles to grams, but we're going to go from grams to moles. So it's the Same process, it's just our numbers and units are a little bit different places. So formaldehyde, which in the past was used to preserve biological samples, has the formula H2CO. This should be H subscript 2CO. It was a typo on my part, so I apologize. How many moles of formaldehyde does 7.55 gram sample represent? So you're going to still start out with what's given and put it over 1. Okay? Follow your units. Whatever unit's on top, you put down on the bottom. Whatever unit you need to go to, put that on top. So 1 mole. It's always going to be 1 mole. And then in order to find the mass of H2CO, we need to find the molar mass first. So 2 H's, 1 C, 1 O. 2 times 1.01 is 2.02. Carbon is 12.01. Oxygen is 16. So when I add those up, what do I get? Okay, so 30.03, this is the molar mass of formaldehyde, so we're going to put that into our conversion factor. Our units cancel. Now we need to divide, so 7.55 divided by 30.03. Think sig figs as well. 3 sig figs.
.51 times 10 to the negative 6.
Type it in one more time. See, you should just get .251.
Right. Which
I
way I got it?
7.5 divided by 30.03.
I got .2511415.
Oh, so no, you didn't need scientific notation?
I kept going. It kept going.
Oh, okay.
I messed up on my homework a lot when I did it like that, so I just.
So this is did everybody get this? With 3 sig figs? Okay. Yeah, this is all you need. And then H2CO. Very good. Okay. You got this one, go ahead and do the next one. You should be able to figure out what tetraphosphorus digoxide is, the formula for that. Okay, I'm going to do the work on the board and you can double check it when you get done. So you're going from grams to moles, just like you did on the last one. And if you get stuck while you're doing these sample problems, make notes to yourself that whenever you get to your homework, you can look back and say, okay, this is where we got this number. This is how we got this number. And think significant figures. This one has 4. And this would be about an 8-point problem. Okay, pretty much every step would be a point. So if you get confused, don't give up on yourself. There's many parts that you can get partial credit for if you need to.
Would your significant figures be 3?
Well, 250.0 is 4 significant figures, so this one would have 4. Questions about that one? It's very similar to the stuff that you've already been doing. So don't change anything. You're just, some of the steps are just a little longer. Okay. Any questions on that one? Did you make anything different? Okay, the last two types of problem is involving molecules. Okay, so let me remind you of what the conversion factor that we use is. Does anybody else need this right here copied?
How'd you get a 0 before the 8?
Well, when you type that in,
Yeah, I did.
did I write it down
twice.
wrong?
I don't know.
Write your calculator real quick.
So that-
So you did 250
Mhm.
divided by
That's a lot.
283.88. Oh, I accidentally wrote a 0.
Okay, that just sorry, that just confused
Does she
me.
point then? Is that what everybody else
Oh,
got?
yeah, that's what I got.
Yeah, my bad. I just wrote it down wrong. So do 0.88. Sorry about that. Thank you for catching it. Okay, any questions on this? Okay, so the last two. So the three conversion factors that you're gonna really need to remember and know how to use all involve the mole. Where's my marker at? 1 mole is the central unit. Now, 1 mole can equal Avogadro's number of particles. This particles can either be atoms if you're talking about a single element, or it can be molecules if you're talking about a compound. So here, you're not going to see atoms, you're going to see molecules, but we treat it the exact same way as we did the last section. Okay, 1 mole can also equal the mass in grams. This is from the periodic table. Okay?
Where should we write that?
This is just a reminder. You should already have this in your notes. Just a reminder of what to do. This also acts as a flow chart. Okay, so if you start in grams, the first thing you go to is moles and then molecules. If you're in molecules, you have to go to moles first and then grams. So this is another little flow chart that you can use. Okay? So last two examples. How many water molecules are in a 10-gram sample of water? Well, 10 grams is what I'm going to start out with of H2O.
Right.
Hopefully you know that formula. Okay.